day, everyone! Are you ready to learn math today? I hope so. In your last lesson, you started to learn about quadratic functions. Some real-life situations were presented to you wherein quadratic functions can be applied. In today's lesson, you will learn more about it and how to represent it. But before we move further, I would like you to take a look at the following videos and pictures. How many of you love basketball game? I'm sure most of the boys are raising their hands.
Do you know the basketball player in the video? Yes, he is Stephen Curry, also known as Wardle Stephen Steph Curry II. He is an American professional basketball player for the Golden State Warriors of the National Basketball Association. Many players and analysts have called him the greatest shooter in NBA history.
Do you know that throwing a ball illustrates a quadratic function? You will see that later. Are you familiar with this bridge? Yes, this is the Golden Gate Bridge of San Francisco, California. This bridge is one of the most famous bridges in the world, and at the time of its construction, it was the longest suspension bridge with a total length of 2.7 kilometers or equivalent to 8,981 feet. A quadratic function is also illustrated in this picture. How? You will find out later. Are you still with me? May I see your smile? Do you know that when we smile, our faces show curves similar to the graph of a quadratic function? So keep smiling! As Mother Teresa said, let us always meet each other with a smile, for the smile is the beginning of love. Math is really everywhere. Please pay attention as we discuss about representing quadratic function through table of values and graphs. These are the curves in the pictures that I had shown you earlier. These curves represent the graphs of a quadratic functions. How do you call this graph? Yes, exactly. We call the graphs parabola.
You already know that a quadratic function can be represented by f of x is equal to ax squared plus bx plus c, where a, b, and c are all real numbers and a is not equal to 0.
Today, we shall represent quadratic functions in other ways. Let us begin by using the table of values.
Let's have the first example. The cables of a suspension bridge are in the shape of a parabola. The parabolic path of the cable when traced can be modeled by f of x is equal to x squared plus 2x minus 3. Represent this function using table of values. To make a table of values for the given quadratic function, let us use the given values of x, then solve for y. To get the value of y if x is equal to negative 3, replace all x by negative 3 and simplify. Showing our solution, y is equal to the quantity of negative 3 squared plus 2 times negative 3 minus 3. The quantity of negative 3 squared is positive 9, 2 times negative 3 is negative 6, minus 3. Performing the operations, y is equal to 0. If x is equal to negative 2, then replace all x by negative 2. Showing our solution, y is equal to the quantity of negative 2 squared plus 2 times negative 2 minus 3. The quantity of negative 2 squared is positive 4. 2 times negative 2 is negative 4 minus 3. Performing the operations, y is equal to negative 3. If x is equal to negative 1, again, replace all x by negative 1 and simplify. Showing our solution, y is equal to the quantity of negative 1 squared plus 2 times negative 1 minus 3. The quantity of negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 3. Performing the operations, y is equal to negative 4. Let's do the same procedure if x is equal to 0. Showing our solution, y is equal to the quantity of 0 squared plus 2 times 0 minus 3. Simplifying, the quantity of 0 squared is 0, 2 times 0 is 0, minus 3. So 0 plus 0 minus 3 is equal to negative 3. So if x is 0, y is equal to negative 3. For the last value of x, we will going to solve for the value of y. If x is equal to positive 1, showing our solution, y is equal to the quantity of 1 squared plus 2 times 1 minus 3. Quantity of 1 squared is positive 1, 2 times 1 is positive 2 minus 3. Simplifying, 1 plus 2 is 3 minus 3 and that is 0. So if x is 1, our y is equal to 0. So let's take a look at the values of y in our table. We are going to get the first differences in y from right to left. Let's start with 0 minus negative 3 and that is equal to positive 3. Negative 3 minus negative 4 that is equal to positive 1. Negative 4 minus negative 3 that is equal to negative 1. And negative 3 minus 0 that is equal to negative 3. Let's take a look at their differences. What can you say? Yes, they are not equal. But let's try to get the second differences in y. Let's start with 3 minus 1 and that is equal to positive 2. 1 minus negative 1 that is equal to positive 2. And negative 1 minus negative 3 that is equal to positive 2. What can you say about their second differences? Yes, they are equal. Finding the differences in y values is one way of showing whether it is a quadratic or not. Take note, if the table of values represents a quadratic function, the second differences must be equal. Let's have another example. The time it takes for the ball to hit the ground after being thrown is defined by the quadratic function f of x is equal to negative 2x squared plus 4x minus 3. Represent this function by table of values. Like in the first example, we will use the given values of x and solve for y. To get the value of y if x is equal to negative 1, replace all x by negative 1 and simplify. Showing our solution, y is equal to negative 2 times the quantity of negative 1 squared plus 4 times negative 1 minus 3. The quantity of negative 1 squared is positive 1 times negative 2, that is negative 2. 4 times negative 1 is negative 4 minus 3. Performing the operations, y is equal to negative 9. If x is equal to 0, then replace all x by 0 and simplify. Showing our solution, y is equal to negative 2 times the quantity of 0 squared plus 4 times 0 minus 3. Quantity of 0 squared is equal to 0 times negative 2, that is equal to 0. 4 times 0 is equal to 0 minus 3. Simplifying, 0 plus 0 is 0 minus 3 and that is equal to negative 3. So if x is equal to 0, y is equal to negative 3. If x is equal to positive 1, replace all x by 1 and simplify. Showing our solution, y is equal to negative 2 times the quantity of 1 squared plus 4 times 1 minus 3. The quantity of 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4 minus 3. Performing the operations, y is equal to negative 1. Let's do the same procedure if x is equal to positive 2. Showing our solution, y is equal to negative 2 times the quantity of 2 squared plus 4 times 2 minus 3. Quantity of 2 squared is positive 4 times negative 2, that is negative 8. 4 times 2 is positive 8 minus 3. Simplifying, negative 8 plus 8 is 0 minus 3 and that is negative 3. So if x is positive 2, y is equal to negative 3. For the last value of x, let us follow the previous procedure if x is equal to 3. Showing our solution, y is equal to negative 2 times the quantity of 3 squared plus 4 times 3 minus 3. 3 squared is positive 9 times negative 2 and that is equal to negative 18. 4 times 3 is 12 minus 3. Performing the operations, y is equal to negative 9. Again, let us show that this table has equal second differences. because this table represents a quadratic function. Let's start with -9 minus -3, and that is equal to -6. -3 minus -1, that is equal to -2. -1 minus -3, that is equal to +2. And -3 minus -9, that is equal to +6. Now, let's get the second differences in y. Let's start with -6 minus -2, that is equal to -4. -2 minus 2, that is equal to -4. And 2 minus 6 is also equal to -4. As you can see, the second differences are equal.
Now, let me see if you can identify which table of values represent a quadratic function.
Is table number 1 quadratic? Let's find out. Let's start by getting the first differences in y. 28 minus 7 is equal to 21. 7 minus 4 is equal to 3. 4 minus 1 is equal to 3, and 1 minus -20 is equal to 21. Now let's get the second differences in y. 21 minus 3 is equal to 18. 3 minus 3 is equal to 0. And 3 minus 21 is equal to -18. Is this a quadratic function? If you said no, you are right. Look at the differences in y values. The second differences are not equal. Let's go to the next example. Is table number 2 a quadratic? Let's find out. Let's get the first differences in y. 5 minus 0 is equal to 5. 0 minus 1 is equal to -1. 1 minus 8 is equal to -7. And 8 minus 21 is equal to -13. Let's get the second differences in y. 5 minus -1 is equal to 6. -1 minus -7 is equal to 6. And -7 minus -13 is equal to 6. Is this a quadratic function? If you said yes, you are right. As you see, the second differences in y values are equal.
Is it clear to you? But wait, there's more. Aside from the table of values, a quadratic function can also be represented by a graph.
To represent the given quadratic function using graph, let us follow these steps. Step 1. Use the table of values. Step 2. Plot the points on the Cartesian plane. And step 3. Connect the points using smooth curve. Consider again the cables of a suspension bridge represented by the quadratic function y is equal to x squared plus 2x minus 3. To represent the graph of this quadratic function, let us use the table of values we have previously done. Step 2. Plot the points on the Cartesian plane. Let's start with the first coordinates. -3, 0, -2, -3, -1, -4, 0, -3, and the last coordinates 1, 0. Let us connect the points using a smooth curve. See, the smooth curve is a parabola. This is another way of representing quadratic function. This is the graph of the quadratic function y is equal to x squared plus 2x minus 3, where a is greater than 0 and the graph opens upward. This parabola is the mathematical representation of the suspension cable of the bridge. Let's have the second example. The time it takes for the ball to hit the ground represented by the quadratic function f of x is equal to -2x squared plus 4x minus 3. We will again use the table of values we had already. Step 2. Plot the points on the Cartesian plane. Let's start with the first coordinates. -1, -9, 0, -3, 1, -1, 2, -3, and the last coordinates 3, -9. Let us connect these points using a smooth curve. See, it's a parabola. This is the graph of the quadratic function y is equal to -2x squared plus 4x minus 3, where a is less than 0 and the graph opens downward. As I've said earlier, there is a quadratic function in throwing a ball. Can you tell me the difference between the graphs of these two quadratic functions? You're right. As you can see, the two graphs have different openings. The first opens upward, while the second opens downward. But when do we have a parabola that opens upward? And when do we have a parabola that opens downward? The value of a in the quadratic function f of x is equal to ax squared plus bx plus c determines the direction of the opening of the graph of a quadratic function. The graph opens upward if a is greater than 0 or positive, and it opens downward if the value of a is less than 0 or negative.
You see, graphs are very much important. These can be used by engineers in construction of bridges and even building. In sports, there are games in which graphs can be helpful. As you learn more about quadratic function, you will be able to think and identify other importance of graphs. That's all for today. I hope you have learned the lesson. You may refer to your Module 15 if you have some questions on this topic. Thank you and God bless. Bye!